Hello, welcome to the video notes for lesson 9-3. This lesson is all about reflections, and this begins on page 19 in your notes packet. So, the learning target, or targets I should say, I can reflect a figure to its image. I can use a rule to reflect a figure to its image. And lastly, I can write the rule of a reflection. Now remember, when we're talking about reflections, a reflection is a flip. And we're going to talk a little bit more about how you can recognize or what a flip looks like in just a few moments when we get on to page 20. But for now, let's go through this example below and see what we end up with. So we're going to move the point. All right, so first, plot the point 2, 5 and label it A. So I am going to go to the point 2, 5. So I start at the origin, go to the right 2 spaces, up 5, and there's my point. I'm going to label it A. Now, the next point is going to reflect, right here. Reflect point A over the y-axis and label it B. So here's the y-axis. So I'm going to reflect this over the y-axis and label it B. Now, the way you do that is basically you count how far away it is to the line of reflection, and then do that many spaces over to the other side. And I'm going to label that one B. Now, so I've completed 7 and 8. Now, I'm going to reflect point B over the x-axis and label it C. So I'm going this way now because the x-axis is here. And it's, let's see, 1, 2, 3, 4, 5 spaces. So I got to count 5 more the other way. 1, 2, 3, 4, 5 spaces, and I'll switch colors again. Now we're going with point C. Now we're going to reflect C over the y-axis and label it D, so we're going this way. So 1, 2 to get to the y-axis, 1, 2 to get to our reflection, here's D. And then we're going to reflect D over the x-axis. And now this time, you might be able to just tell, well, if I reflect it, I'm going to end up back here. So basically, at the same point as A is point E. So reflecting is flipping it over a line. So it has to be the same number of spaces or same distance. If you think about a reflection in a mirror, if you were standing a foot or 2 feet away from a mirror, your image would look like it's about the same distance, or exactly the same distance away. So, last question at the bottom, name point E. Point E is the same as point A, 2, 5. Alright, that is reflecting. Okay, so we're going to go through page 20 together. So let's go ahead and take a look at page 20. And there's a lot we've got to talk about on this page, so make sure you're listening and paying attention. A reflection, or flip, and you've heard me say that a bunch of times, is a rigid motion that flips a figure over a line called the line of reflection. Alright, so I want to point out a couple of things here. I've said flip many times. Rigid motion means basically that the figure or the point or whatever you're flipping stays the same, it doesn't change, over a line called the line of reflection. That's something else that's really important to be aware of. Usually we flip over one of the axes, but when you get into some heavier duty reflections, you can flip over any line you want, and it can be, besides vertical and horizontal, it can be a diagonal line as well. Okay, so let's put a star up at the top and write down something really important. When you do this, the image is congruent. Just like when we did translation, the image is congruent. Remember our congruent symbol. However, the orientation has changed. Orientation changes. Now, when we did the translation in the last lesson, the slide, the image was also congruent, but the difference is, one of the difference, is the orientation would stay the same. With reflections, the orientation changes. And we can't really see that with this example in the picture here, but in the picture below, at the bottom of page 20, we'll talk about what the orientation is. So if point A is on the line of reflection, so right here, then its image itself is A prime is itself, so it basically stays the same. So if you've got the point right on the line of reflection, it stays the same. If point B is not on the line of reflection, then B and B prime are on opposite sides, so they're flipped over. Then they are on a line perpendicular, so that's this right here. And perpendicular means that it creates a right angle. Okay, perpendicular is kind of like the opposite of parallel. Parallel are two lines that never touch. Perpendicular are lines that do touch or cross, and when they do, they create a right angle and are the same distance from the line of reflection. So if you remember on the other side, on page 19, when I would count the number of spaces, the reason I did that is because the reflection is the same number of spaces on the other side. So this is 3 this way, and this is 3 this way. The general rule for a reflection is a reflection over the y-axis. Watch what happens here. So your original point, xy, so let's say it's 1, 2, becomes negative x, or the opposite of x and y. So if x is 1 and y is 2, the opposite of 1 is negative 1. Now, the reason why I say the opposite is because if we had started with a negative number, then the opposite of a negative number is a positive number. So be careful. Reflection over the x-axis, notice what stays the same, the x value, but then the y values change. So, let's take a look at our example at the bottom of page 20. So, describe in words the rigid motion that maps square cake to its image. So notice square cake is down here below the x-axis. Oh, by the way, these labels are a little bit messed up, so cross them out. I have a feeling whoever created this rotated it, and that's why it looks the way that it does. The negatives are still where they need to be, but everything else is a little... This should be the y-axis, and this should be the x-axis. But all of you know that. Alright, so describe in words the rigid motion that maps cake to its image. So here's the original, here's the image. So to get this up here, we're not sliding it, because if we did, then A prime would be up here where K is. We're flipping it. So it's a reflection over the x-axis. Use arrow notation to describe the rigid motion that maps square cake to its image. So what we're doing is we're basically rewriting all the points. So we've got C, which is point 2, negative 2, that's right here. And that's going to C prime, which is right here. That is 2, 2. Then we have letter A, which is 8, negative 2. Flipping over the x-axis, getting us A prime. Now it's 8, 2. K is at 8, negative 8. K prime, 8, 8. And the last one, 2, negative 8. E prime is 2, 8. Alright, so there's our arrow notation. Now we're going to write a rule. So if you notice, all the x values stay the same. 2, 8, 8, 2, 2, 8, 8, 2. So x and y, the point that we start with, reflects and x stays the same. What happens to y? Well, y becomes the opposite of what it started, so the way you write that is negative y. And there is your rule. Alright, we'll be doing lots of practice with this. Reflections aren't bad, but they can get confusing if you don't practice. So, if you had any trouble, go back and rewatch the video. Good luck, and we'll see you in math.